Hi, my name is Gilbert, and I'm presenting a study that was made in collaboration with Max Zellers at Kiel University and David House at KTH Stockholm. The study is about compounds in interaction, patterns of synchronization between manual gestures and lexically stressed syllables in spontaneous Swedish. Speech prosody and gesture share a number of common functions, and it has been argued that the two should be treated as part of the same system in terms of their linguistic functions. One of these common functions is the signaling of prominence. And this is me, by the way, and these are my co-authors, Meg and David. So back to prominence. In fact, gestures have been found to be synchronized with elements of prosodic prominence, such as stressed syllables or pitch accents. For instance, eyebrow raises have been found to precede pitch accents by an average 60 milliseconds in a corpus of English face-to-face dialogue. So temporal alignment between gesture and prosody can probably be regarded as a basic mechanism of spoken language production, which indeed has been shown to be acquired as early as at the age of 16 to 18 months. However, we still know too little about the constraints that phonetic and phonological prominence structures may put on patterns of gestural movement or alignment. For instance, how well are different types of gestures or gesture phases aligned with units, such as stressed syllables? And does the lexical phonological level of prominence play a role in the planning and execution of gestures? This would at least be a possible prediction if we assume that speech and gesture production arise from a common generation process. So this paper aims to approach these questions by studying the synchronization of manual gestures and stressed syllables and compound words in spontaneous Swedish dialogue. Compounds make a particularly grotesque case because in Swedish, a compound comprises two lexical stresses, a primary and a secondary one, which are clearly distinguished phonologically because they associate differently with tones, which I will explain on the next slide. So the question we ask in this paper is whether both stresses, the primary and the secondary stress, also associate with gestures and whether and how they differ in this respect. So before I present the method, I should say some words on Swedish compounds. Compounds can be defined as words that are formed from other lexical elements or morphemes, such as the word konferensartikel, meaning conference paper. In Swedish, compounds usually have two lexically specified stressed syllables, a primary and a secondary one. And the two stresses in a compound are located on the same syllables as in the underlying simple words or morphemes, as we can see in this example. The primary stress is usually found in the first element, and the secondary stress in the second element. So it's konferensartikel. I mentioned tones on the previous slide. Indeed, in addition to lexical stress, Swedish also has a binary tonal word accent distinction referred to as accent 1 and accent 2. And these word accents are assigned according to phonological and morphological rules, where compound words regularly receive accent 2. Now, in the Stockholm dialect, which is the one tested in the study, this accent 2 is realized as a tonal fall in the primary stress, usually modeled as a high tone plus a low tone, H plus L. However, the secondary stress can also be associated with a tone, and this happens as soon as the word receives phrase level prominence. Such prominence is realized through an additional high tone, which is realized after the tonal fall. Now, compounds are special in this respect because in compounds, this tone associates always with a secondary stress. It doesn't just come directly after the fall, it associates with a syllable. And the result is thus a two-peaked pitch pattern, which in compounds is anchored in the two syllables. So konferensartikel. Now, what we want in the study is whether also gestures might somehow align with the stressed syllables. We used selected dialogues from the spontaneous corpus from 10 speakers. And these data we first labeled manual gestures, and we then identified all compounds, which were 122 tokens, and segmented them acoustically. Synchronization was then studied in two steps. First, we simply counted overlaps of gesture phases with the primary and the secondary stressed syllable. And second, we measured the temporal alignment in seconds between the onset of a stressed syllable, be it primary or secondary, and the nearest gesture phase transition. More details on the method can be found in the paper, but I should at least explain how we labeled gestures. So the gesture labeling was carried out by annotators in Milan using only the video. And hand gesture phrases and phases were identified in two passes following McNeil and Camden. And once the gesture phrases were in place, the second annotation pass was used to divide them into phases. And the phases were, following McNeil, preparations, strokes, holds, and retractions. However, we also added two phase types in order to capture beat gestures, because beat gestures can be difficult to classify using the traditional phases, since they sometimes only involve a biphasic movement. So in these cases, the gestures were labeled based on the relationship of the movement direction to the location of the visually prominent beat. So into what phases the hand moves towards the location of the rhythmic beat, and thus the perceived timing of the beat is the end of the toward phase. And in the away phases, the hand moves away from the location of the rhythmic beat, either before the toward phase in preparation for it, or after the toward phase as a retraction. As for the results, in the first analysis step, we explored patterns of overlap between stressed syllables and gesture phases. And to this end, we first identified the compounds that had at least some overlap with the gesture, and these were 56 out of the 122 compounds in the material. We then qualitatively inspected the configurations of gesture phase labels that overlap with the word and classified them into a smaller number of categories. And this was done in order to identify general recurrent patterns. The table shows the results of this categorization. So this categorization focused on whether or not either the primary stress, referred to here as S1, or the secondary stress, S2, was co-occurring with the movement phase. We did this assuming that movements can potentially serve as a visual prominence cue, but note that this is just a means of to simplify the data. The analysis is still exploratory, and we don't want to make any strong claims here as to whether gesture phase types are prominence lending or not. It's just one possible way to classify the data. The table shows that the gesture phases could be coordinated with the stressed syllables in different ways. First, a single gesture phase could be ongoing during both of the stressed syllables, and this arose in 32 of the cases, as shown in the top portion of the table. Alternatively, the two stressed syllables could be accompanied by different gesture phases, either both by movement phases, or one syllable was accompanied by a movement phase and the other one by non-movement phase, such as a hold. So for instance, when there was a stroke that overlapped with both S1 and S2, as on this first example, but then turned into a hold, this was classified as movement in both S1 and S2. But when the shift from the stroke to the hold occurred already during the first stressed syllable, as here, this was classified as movement in only S1. Right, another way to look at the data is to say that in the majority of the cases, both stressed syllables were accompanied by movement phases and the hand gestures. But when only one syllable was accompanied by movement phase, this was almost always the first stressed syllable. And in only two cases, the second stressed syllable was accompanied by movement phase when the first stressed syllable was not. For the second analysis, we identified the nearest gesture phase transition for each S1 and S2. And this was done for all 56 words that were overlapping with the gesture. And among these, 100% of the primary stressed and about 90% of the secondary stressed syllables overlap with the gesture. We then calculated the temporal distance in seconds between syllable onset and the nearest phase transition. And the results of these measurements are shown in these box plots. So in the figure, gest phase denotes the type of gesture phase that starts nearest to syllable onset. And time lag on the y-axis denotes the time from gesture phase onset to syllable onset, where negative values below 0 mean that the syllable starts before gesture phase onset. There appear to be differences across the two stressed syllables. We can see that all 6 phase types may arise in the first stressed syllable, but only 4 of them may arise in the second stressed syllable, since we do not observe any onsets of preparations or toward movements aligned with the second stressed syllable. For the primary stress, stroke phases and toward phases, those 2, tend to be more tightly aligned to syllable onset than the other phase types, since for these 2 phase types, the median shown in the line, by means of the line in the middle of the box, is closer to 0 on the y-axis compared to the other phase types. So preparations, for instance, they display a rather constant alignment slightly before syllable onset. And also toward phases and preparations are less variable in the timing compared to other phase types, which is indicated by the relatively small boxes. And the largest variation is clearly observed for retractions. For the secondary stress, however, retractions as well as holds tend to align to syllable onset. The median is quite close to 0. And all 4 phase types display a moderate level of timing variation. So, but due to the small size of the dataset, our results should be regarded as exploratory. However, the data reported here clearly suggest, on the one hand, similarities, but also an asymmetry in gesture behavior between the first and the second stressed syllable and compounds. Both S1 and S2 seem to display close alignment to gesture phase transitions, but the distribution of available gesture phases is more constrained in S2 than in S1. In the study, we focused on the synchronization of gestures and stressed syllables, but not directly on the role such synchronization might play for prominence. However, ultimately, we are interested in how gestures contribute to prominence, and this perspective will have a certain impact on the discussion of the present results. So as mentioned in the beginning, previous studies have shown that gestures often coincide with phonological elements of prominence, such as stressed syllables or pitch accents. And a question that suggests itself in the light of such findings is whether this temporal alignment is a mere effect of a common generation process, or whether patterns of synchrony and alignment themselves can also fulfill communicative functions. It is still an open question how exactly gestures contribute to prominence, or in other words, which characteristics of gestures are prominence lending. It could, for instance, be certain types of movements that visually add to prominence, but possibly also the alignment patterns between gestures and stressed syllables per se. I will now return to our present results again, and thereby get back to the potential prominence lending functions of gestures. We found that movement phases were somewhat less likely to arise in the second stressed syllable than the first. We also found evidence of close alignment of gesture phase onsets with both primary and secondary stressed syllable onsets, although fewer gesture types were found to be aligned with the secondary stress. In other words, both primary and secondary stressed syllables might be regarded as important landmarks on the coordination of gesture and speech, but there is certain asymmetry between S1 and S2. Interestingly, it was not only necessarily only the stroke phase which was closely affiliated with the prominent syllables. This is notable because the stroke phase is considered to be the only obligatory gesture phase and is often the focus of attention of studies investigating prominence relations between gesture and speech. And while many of our stressed syllables were accompanied by gesture strokes, they could also be accompanied by other gesture phases. And these could be movement or non-movement phases, such as holds. Also, in over half of the compounds in our study, both stressed syllables were accompanied by the same gesture phase. However, when the two stressed syllables were accompanied by different gesture phases, there was an asymmetry between the two syllables. It was much more frequent for S1 to be accompanied by a movement phase and S2 by a non-movement phase than the reverse. So if we take movement phases to be more visually prominent than non-movement phases, then it seems that the first stressed syllable may have some kind of privilege in terms of carrying prominence compared to the second stressed syllable. This asymmetry might suggest that gesture is a part of the prosodic marking of a compound as a single coherent word, and that it supports the distinction between a main prominence, the first stressed syllable, and a secondary prominence, the second stressed syllable. Additional evidence for an asymmetry between the first and the second stressed syllable comes from our alignment measurements. Movement phases seem to be closer aligned to the first stressed syllable than to the second stressed syllable. And the first stressed syllable can also be accompanied by any gesture phase, while we found no preparation or to what phase, to what movements accompanying the second stressed syllable. However, the second stressed syllable showed a relatively narrower alignment with the onset of retraction phases than the first stressed syllable. And because the onset of the retraction may be considered the end of the gesture, the alignment of the onset of the retraction with the second stressed syllable could be related to the final prominence of the compound signaling the upcoming end of the word. Now, a possible conclusion of this study might be, we suggest, that the way gestures are aligned with compounds tends to mirror the lexical phonological stress levels in compounds. And generally speaking, then, the study provided more evidence for the common function of prosody and gesture in signaling prominence, and possibly also for a common generation process. Further work should extend this analysis into additional types of body movements, such as head movements, and also consider additional kinematic detail in order to be able to more precisely measure temporal alignment between gestures and speech. And similarly, acoustic measures such as F0 and durations should be integrated to study not only temporal relations, but also, let's call it, spatial relations between movements in the gesture space and movements in the acoustic space. And finally, the study should also be extended to non-compounds. Thank you very much for listening.